Hello and welcome to this video on how to analyze a mimic model in the free JASP software. My name is Geiser. I'm an instructor and statistical consultant with QuantFish. So first of all, what is a mimic model? A mimic model is a confirmatory factor analysis with covariates. And I will show you an example here. So here you can see a factor model with two latent factors, F1 and F2. Each factor has three indicators. And in the mimic model, those factors F1 and F2 are dependent variables, and specifically they are regressed on one or more observed or manifest variables. In this example, X1, X2, and X3. So those are single indicator manifest variables that we regress the factors on, and those could be variables like, for example, gender and age, for which oftentimes we have only a single manifest variable in our data sets. You could think of this mimic model as being a hybrid model between a structural equation model with latent variables and a standard regression model with observed variables, specifically a multivariate regression model where you can have more than one outcome variable. And so this is, so to say, on the side of the predictor or exogenous variables, this model has manifest variables. On the side of the endogenous or dependent variables, this model has latent variables. Now let's take a look and see how this model can be analyzed in the JASP software. So here you can see the JASP software. You can download the software for free from the internet, and it's a very neat little program that allows you to run a variety of statistical analyses through a point-and-click graphical user interface, and it's very straightforward to use and very user-friendly. The first thing that we have to do is open a data file, and this can be done by going to the left-hand side to the main menu, and then we can click on Open, and we can select a file, for example, from our hard drive. So in this case, I have a data file here in my Documents folder. And so I'm going to open this one. In this case, I have a text file that I will open here, and it's called mimic.txt. You can also open SPSS data files in JASP like this one here, or you could open an Excel file in JASP, so that's very convenient. So we're going to open this text file now, and then you can see this text file has four variables. Those will serve as the indicators of a latent factor in our example. And then also we have two manifest variables, X1 and X2, that will serve as covariates or predictors of the latent factors. Now, where do you find the mimic model option in JASP? You find that under SEM. SEM stands for Structural Equation Modeling, and JASP uses the LAVAAN package in R to fit different types of confirmatory factor models and structural equation models. So behind the scenes, LAVAAN is being used here, and we can also then, as we will see, we can take a look at the LAVAAN syntax. However, you don't have to use syntax here. It's all point and click, which is very convenient. So let's click on SEM, and then you can see that there are different options, and one of them is a mimic model. I have other videos on this channel where I discuss other options in JASP, for example, the mediation modeling option and the latent growth curve modeling option. So if you're interested in that, then please feel free to also check out those other videos. Now we're going to click on Mimic Model, and we can see that then on the left-hand side, we have an input screen where we can select our variables for the analysis. And on the right-hand side, you have your output screen. And so already some tables have been prepared here for a chi-square test of model fit and for parameter estimates. Right now those tables are empty because we have not selected any variables yet. So the first thing that we're going to do is we're going to select indicators for our factor, and notice that one limitation of the mimic option in JASP is that it can handle only mimic models with a single factor at this point. In the example that I showed you earlier, you could see that a mimic model can also be specified with more than one latent factor, and that's unfortunately something that currently we cannot do in JASP, at least not through this option. If you wanted to have more than one factor as an outcome variable, you would have to go through the SEM option here at the top, structural equation modeling, and then you would have to specify the LAVAAN syntax for that. So this doesn't work through point and click currently. So let's do a model with a single factor. And so I'm going to select y1 through y4 as my indicators for a factor. So these go into the indicators box. So this will then define the factor model with a single factor and 4 indicators. And x1 and x2 are my predictors or covariates of the latent factors. So we're going to put those in the predictors window, and then JASP executes the analysis. You can see then we get a chi-square test of model fit. There's one for the baseline model, which is the null model here, and so this one is very large, has a very large chi-square and a very small p-value, indicating that it does not fit the data well. So that's just the baseline model that assumes that there are no associations between the variables in the data set. Our actual target mimic factor model has 8 degrees of freedom, has a chi-square of 10.98 and a p-value of 0.203, which means that this model is not rejected at the 0.05 level. So this model fits the data well. Next are parameter estimates, and first are the parameter estimates for the structural predictor or regression model, where we regress the one factor on x1 and x2. And so you can see here the regression coefficient for the regression of the factor on x1 is estimated to be 0.158. Its standard error is 0.071. The z-value is 2.21 and the p-value is 0.027. So this indicates that the regression coefficient for the regression of the factor on x1 is statistically significant at the 0.05 level. You can also see that the 95% confidence interval here does not include 0, again indicating that the coefficient of 0.158 is significant at the 0.05 level. The coefficient for the predictor x2 is 0.499, and it's also significant at the 0.05 level and even at the 0.001 level because the p-value is smaller than 0.001. Once again, the 95% confidence interval does not include 0, indicating that there's also a significant association between x2 and the factor. Below the structural model coefficients table, we obtain a table with factor loadings. And so here you can see the estimated factor loadings under estimate, the standard error, the z-value, and the p-value. And so here you have to be careful because these estimates here are actually not the standardized loadings. In order to obtain standardized factor loadings, we can go to Options and then click on Standardized Estimates. When that option is activated, you can see that the estimates in both tables change. So now we have standardized parameter estimates for both the structural coefficients and for the factor loadings. And so this shows us for the factor loadings that they range between 0.515 and 0.753. So they're not terribly high, indicating that those indicators are not super reliable measures of this factor. What we can also do here under Options is we can look at the LAVAAN syntax for this model. So if you wanted to learn the LAVAAN package in R that is used here to carry out these analyses, then you can take a look at the syntax and you can learn how this model would be specified in the LAVAAN package in R. Also, you can output R squared. So when you click on that, we can see we get the R squared for both the observed variables, which are the indicators of the factor. So those R squared values indicate how much of the variance in the indicators is accounted for by the factor that they're supposed to measure. And then also you get an R squared for the factor. The factor here is referred to as y, and so that R squared of 0.207 shows us how much variance in the factor is accounted for by x1 and x2, the two predictors of the factor. So in this case, 20.7% of the variance in the factor is accounted for by x1 and x2. You can also see here that there's an option for additional fit measures. So in addition to the chi-square test of model fit for this mimic model, we can also get a whole bunch of other fit indices that you might be interested in, such as the comparative fit index, the root mean square error of approximation, and a whole bunch of other fit measures as well. You can also select a method for estimation, either the standard method for maximum likelihood estimation, or you can obtain robust standard errors, or even you could obtain bootstrap standard errors here as well. Furthermore, under plots, we can select a model plot, meaning a path diagram of this model. So when we click that option, then a path diagram is being generated by JASP, and you can see here that this is the mimic model that we wanted to specify. We have a single factor labeled y with 4 indicators, and then there's the 2 covariates of this factor, x1 and x2. We can also display the parameter estimates in this path diagram by clicking here on parameter estimates, and then those will be imported into the path diagram. Notice that those estimates are not standardized, so you have to be careful with that, because here this is not the full, at least it's not the fully standardized solution. We can also click on advanced, and under advanced you can see that JASP uses full information maximum likelihood estimation as the default, which is nice because it means that if you have any missing data, those will still be included in the analysis using full information maximum likelihood, which is desirable. You can also see that the default estimator here is being used, and that's maximum likelihood. You could also select other estimators that are shown here on the right hand side. I hope you found this video useful to learn about how to run a mimic model in the JASP software. If you did, please subscribe to this channel, check out the description for additional resources, including our newsletter and also courses that we offer through QuantFish, and I'll see you next time.